Good afternoon. We are going to take notes on sections 7.8 and 7.9. They're very closely related, so we can do both of them at the same time. The Pythagorean Theorem and its converse. Hopefully you've heard of the Pythagorean Theorem, and we're going to add on a little bit to your understanding of the Pythagorean Theorem. Here it goes. Pythagorean Theorem. If a triangle is a right triangle, then the square of the hypotenuse, which is the longest side, the square of the hypotenuse is equal to the sum of the squares of the legs. And the formula is a squared plus b squared equals c squared. So this would be a and b would be legs. So this is legs squared plus a different leg squared equals the hypotenuse squared. Okay, so let's do this in more of a Cliff Notes form. If triangle ABC is a right triangle, so it has a right angle here, then the sides are related by a squared plus b squared equals c squared. Now, the hypotenuse of the triangle is always the side opposite the 90. It's also the longest side. We designate the hypotenuse as side C, and it must be on the right-hand side. Now, A and B are the legs, and they are interchangeable. As long as they are the legs and they're on the left-hand side, you're good to go. All right, let's practice using this. Example 1, find the value of y. So we have three sides. We have two legs, A and B, and an unknown C. And again, the side across from the 90 is the hypotenuse. So we're going to use Pythagorean Theorem, a squared plus b squared equals c squared. Let's substitute in the values. So 5 is a leg squared plus 10 is the other leg squared equals y squared. That is your equation. Now we solve. First, do the exponents. 5 times 5 is 25. 10 times 10 is 100. Y times y is y squared. Then add the two on the left. So 125 equals y squared. To get y alone, you're going to take a square root of both sides. 2 y's, 1 comes out. Because it's a side length, we don't worry about the negative. We only keep the positive y. And 125 is 25 times 5. So 5 times 5 times 5. 2 factors of 5, 1 comes out to the front. So y equals 5 radical 5. And as usual, we leave it exact unless we're told otherwise. All right, let's do another example, a little bit more complex. Find the value of y. So again, the hypotenuse is opposite the 90, so that's our c value. And then a and b are the interchangeable legs. So using the formula, a squared plus b squared equals c squared, we fill in our values. A is y minus 1 squared, plus b, which is 5, and c, which is y. There is our equation. Okay, so to find y minus 1 squared, you need to actually multiply it out. So you need to multiply y minus 1 times y minus 1. So y times y is y squared. Y times a negative 1 is negative y. Now distribute the 1. Negative 1 times y is negative y. Negative 1 times negative 1 is positive 1. So adding like terms, we get y squared minus 2y plus 1. That is our perfect square. Okay, so now let's just bring down the other values. 5 times 5 is 25. Y times y is y squared. Okay, so even though we've got y squareds and regular y's, we're going to add or subtract to get y's to the left and numbers to the right. So I'm going to subtract y squared over to the left. And 25 plus 1 is 26. So I'm going to subtract 26 over to the right. So now I've got something interesting that happened. The y squared's completely added out. And I have a negative 2y equals a negative 26. All right, to get y by itself, multiply by the reciprocal, 1 over negative 2. The negative 2's cancel. A negative divided by a negative is a positive. And 26 divided by 2 is 13, and that is our answer. Now, let's say, though, for argument's sake, that the y squared didn't go away. It didn't subtract out like it did. If that's the case, if there is a y squared left, you have what's called a quadratic, and you need to get all of the values equal to 0. So you would add or subtract everything equal to 0, and then you would factor the left. If that didn't work, you could use the quadratic formula. And from that, you would get 2 answers and would need to figure out which one makes sense. Obviously, negative numbers don't make sense, so in that case, you would only keep the positive number. So there will be a couple where the y squared doesn't actually subtract out. Okay, that is Pythagorean theorem. You can flip the page. All right, the converse of the Pythagorean theorem. Converse is another word for reverse. It says, if the square of one side of a triangle is equal to the sum of the squares of the other 2 sides, then the triangle is a right triangle. So Pythagorean theorem only works with right triangles. In the converse, you're using Pythagorean theorem to prove it's a right triangle. So it's exactly the reverse process. So the converse says, if the sides are related by a squared plus b squared equals c squared, where of course a and b are legs, c is the hypotenuse. Here's our right angle. If that is the case, then we know that the measure of angle C really is 90 degrees. Therefore, it's a right triangle. Now, if you're not sure which one is the 90 degrees, then all you need to do is make sure that C is the longest side. Whatever number's biggest, that's your C. The other 2 are the legs. And the leg can be A or B for these choices. It's only the longest side that you have to be careful that it goes on its own on the right-hand side. Okay, let's do an example of this. If triangle ABC has side lengths measuring radical 10, 1, and 3 centimeters, is it a right triangle? So the first question you need to answer is, obviously this isn't to scale, which side is the hypotenuse? So to find the longest, we need to know what radical 10 is. So square root 10, if you remember, to estimate it, you want the perfect square lower than 10, which is 9, and the perfect square higher than 10, which is 16. Square root 9 is 3, square root 16 is 4, 10 is in between, and it's a little closer to 9. So radical 10 is about 3.2. So if this is 3.2, it is obviously the longest side. That would be our C value. So using the relationship a squared plus b squared, we want to know, does that equal c squared? Because remember, the converse is proving it's a right triangle. If this relationship is true, then it is a right triangle. This relationship, however, might not be true, in which case it is not a right triangle. All right, so let's fill our values in. The legs are the smaller 2, so 1 squared plus 3 squared. Does that equal the hypotenuse? And I'm going to use the radical 10 now, because we only needed the 3.2 to figure out it was the longest. So that is our equation. We are not solving, we are proving. So double yellow lines mean do not cross. When you prove, you just simplify straight down. So let's do the easy side first. 1 times 1 is 1. 3 times 3 is 9. We get a 10. The question is that what we're going to get over here? All right, so square root 10 times square root 10. The radicands get combined. It's square root of 10 times 10. 2 tens, 1 comes out. And what do you know? A squared plus b squared did equal c squared. So our conclusion, therefore, is that triangle ABC is a right triangle. And that is how you use the converse, is to prove it's a right triangle. All right, so we're going to add on, because this is probably something you've seen before, but we're going to add on something a little bit new. Roman numeral 3, we're going to determine the type of triangle, right, obtuse, or acute, and the longest side, C, actually will give us the type of triangle we have. So, according to the converse of the Pythagorean theorem, if the square of the longest side is equal to the sum of the squares of the two legs, a squared plus b squared equals c squared, and it's really important in here you recognize this is an equal sign, then the angle opposite the longest side must be a right angle, which would make it a right triangle. So that's the one we already have. Remember that the longest side is always the one opposite the right angle. Okay, so that's situation number 1, where it turns out to be a right triangle. Okay, here's situation number 2. If the longest side, oops, I wrote side twice. If the longest side, C, is really long, like this one here, see how this side AB is really long? It's not just a little bit longer, it's lots longer than the other two. Then the opposite angle, C, must also be really big. An angle greater than 90 is called an obtuse angle, which would make the triangle an obtuse triangle. So if the longest side is really big, C has to be really big, in which case it is an obtuse angle, which makes it an obtuse triangle. We'll get into the math of that in a second. Okay, third scenario. If the longest side, C, is really small, so it's not very much longer than the other sides, then the opposite angle, C, must also be really small. An angle smaller than 90 is called an acute angle, which would make it an acute triangle. So here is your side. This is your longest side, but it's not very long. So it's small compared to what it could be, being the longest side. If that's the case, then the angle opposite has to be an acute angle. This means that A and B must also be acute. If all three angles are acute, it's an acute triangle. So the size of side C can tell you the triangle type. Okay, flip the page and we'll put this in terms of the formula. Okay, so first one's first. If A squared plus B squared equals C squared, and C is, remember, your longest side, it means that the measure of angle C must be perfectly 90. So angle C is a right angle, and the triangle is a right triangle. So in this case, your C value is very well balanced with the other two. Okay, 8.4. Let's say that the hypotenuse, the longest side, isn't very big. In fact, it's smaller than A squared plus B squared. If that's the case, it means that the longest side is not very big. So the measure of angle C, which is opposite, is going to be less than 90 degrees. This makes it an acute angle, which means the whole thing is an acute triangle. And that means that all angles are acute. And again, we're looking at how the length of the longest side compares, and that gives us the angle across from it. Okay, third scenario. Let's say that the longest side is really long. So A squared plus B squared is less than C squared. This thing's big. That means that the measure of angle C is greater than 90 degrees, which would make it an obtuse angle. If one angle of a triangle is obtuse, the whole triangle is obtuse. All right, let's practice this. Classify each triangle with the sides of the given lengths as acute, right, or obtuse. Okay, and I've done parts of this for you already. Okay, so here we go. We have sides 5, 12, and 14. 14 is the longest side length, so that's going to be our C. So when you put it into the formula, that's the one that's going to be by itself. So the question is, how do those relate? Okay, so first do the exponents. 5 times 5 is 25. 12 times 12 is 144. We're trying to figure out the relationship to the C squared, which is 196. Well, 25 plus 144 is 169. When you compare that with 196, 196 is greater than the 169, which means our C squared is greater than the rest of it. So it's a really big angle, which means the angle opposite is obtuse, so it's an obtuse triangle. Okay, let's do the middle one. All right, we have a triangle with side lengths 6, 7, and 8. 8 is the longest side, so that's going to be our C and go by itself. The other two are legs. So exponents first. 6 times 6 is 36. 7 times 7 is 49. Big question mark. 8 times 8 is 64. Now add these together. 36 plus 49 is 85. Now we compare it to the 64. 85 is greater than 64, which means our C value, our longest side, is very small. The C squared is very small. That means that it is opposite an acute angle, so it is an acute triangle. All right, last one. Radical 3, radical 4, radical 5. Obviously, radical 5 is the longest. That's our C, so it goes by itself. Do the exponent first. Radical 3 times radical 3 is regular 3. Radical 4 times radical 4 is regular 4. Radical 5 times radical 5 is regular 5. Add it up. 3 plus 4 is 7. When I compare that with my 5, 7 is greater than 5, which means a squared plus b squared is greater than c squared. So this is also an acute triangle. So the only way it can be a right triangle is if a squared plus b squared is exactly equal to c squared. Otherwise, it's obtuse or acute. Okay, example 2 and the last one on the notes today. Let's find the measure of y, and we need to label that. Y is this one right here. Find the measure of y if df is 6, let's label that, and the measure of angle C is 90. Okay, so other piece of information that should have been in this, y is a median, which of course means it goes from a vertex to a midpoint. We need that piece of information. So if y goes from the vertex to the midpoint, it means that df and fe are the same, so that one must be 6. Now, a long time ago, we had a theorem that says in a right triangle, the median that goes to the hypotenuse actually splits the hypotenuse into 2 equal pieces, and itself is also the same length. So that's going to be a 6. So just to remind you of the theorem, and this is the explanation, if a right triangle has a median to its hypotenuse, then the midpoint of the hypotenuse is equidistant to all 3 vertices. And from that, we figure out, therefore, y must be 6. So this is an old theorem that we used to know. I wanted to remind you of it because it's going to come up on the homework. All right, that is the end of the notes. Have an excellent rest of your day.